Okay, got some of my mantle projects, those that anyone would play with for a little while, move on to other things, stick it up on the mantle, on a shelf somewhere, which these have been. This is sort of a breadboard, a test bed, if you like, for an AM radio I was building. It, for those of you who won't be familiar, it's not a superhet. It's a TRF, tuned radio frequency. Works a little bit differently, often not as well. They tend to feedback and oscillate RF. This one does work, not perfectly, but you know, well enough. A lot of these component leads are quite a bit longer than they should be for RF. The reason for that is this is a test bed, it's a breadboard, and I don't want to use up components like they're free. They're not. So I keep the leads long just for testing purposes. If I clean this up, yeah, it probably would improve its operation a little bit. It's not a heck of a lot to it. There's some tubes missing out of it right now, which I borrowed for other stuff temporarily. A couple of RF gain stages, tuner. It's this 3-section tuning cap here. A little bit more about that later. I'm only using 2 sections of it to tune these 2 coils. This one here is a little hard to see. See, it really only needs 4 tubes to operate, and even one of those is nothing but a rectifier. So the whole meat and potatoes of it is 3 tubes. One of those is an audio amp. The other 2 were 6AU7, which are the real heart of the beast. Here's a gain control. These are long cutoff tubes. That means they're very easy to control. They're used in old ADC controls, RF amplifier stages, IF stages, for the knowledgeable for radios. As I said, this is a tuned radio frequency. There's no oscillator on here. It's just receiving and detecting. This is the output stage. This thing actually drives the speaker fairly well, although this transformer is huge compared to what I needed for this output. It puts out a couple of watts. But it matched this. I think these 2 parts, power transformer, speaker output matching transformer. Sorry about that. This guy here, speaker matching transformer. I'm pretty sure they came out of the same, whatever it was I disassembled. Don't remember. Guess it don't matter. Just about all of it's scrap material. This plate was, and I had to get that new and punch it. But nearly everything used in this is junk and still usable. I doubt that I'll ever take this apart or really do anything else with it. It's really dusty. It's been sitting on my project shelf for years without having been touched. Could use a good clean, and I may pull it out and fire it up once for a demo or whatever, but chances are I'm not going to get to that. I got too many other things going on these days that require my attention. I want to focus on this a little bit, this variable cap. There's nothing particularly mysterious about it. Just a bunch of metal plates that are connected to the ground, meshing adjustably with other plates that tie into other parts of the circuit. Mechanically, it's a couple of bearings with a central rod made of brass. These plates are made of aluminum. They don't touch. These plates I'm moving do not touch these other ones. There's a real close gap, which makes it a variable capacitor. And so, the next thing I'm going to show, I used one of these where I pulled all of these plates off. All of them. The ones on the rotor shaft and the ones stationary. I've got bunches of these things, so it wasn't a great sacrifice. Now this was made probably around 1990 or so, just on a whim. I was looking through some old vacuum tube manuals, and they had a circuit in there I thought was intriguing, and that is partly used in here. The rest of it's mine. But it does work. But the other thing I'm going to show you is one of these for a completely different function. Let's get rid of this. Put this other little beastie in here. Get a little bit better view of it. Okay. This is a homemade brushless DC motor. This was, I made this, I guess, around 1980, maybe 81. I used to work in a repair shop all those years ago. Microwave ovens, radios, stereos, you name it. If they could carry it in the store, I had to fix it. And sometimes not. But as a result of that, those years, I got quite a bit of scrap material. You know, customer brings something in, they didn't want to pay to fix it because it would have cost too much. It was just cheaper for them to have bought a new one. And they didn't want to pay the service fee. Well, when they did that, we got to keep their stuff. Now some of it was still too expensive to fix and would just be scrapped out, usually by me. I'd save all the pretty bits. Some of it actually was repairable and worth doing so. Stereos and that kind of thing. You know, somebody didn't want to pay $75 to replace a fuse. That's understandable. So they'd say, well, I'm not going to pay the $35 to have you look at it, so we keep it. That's how they play. It's never was comfortable with that, but it did get me an awful lot of junk in my junk pile stuff. This, like just about everything I make, is made almost entirely of junk, recycled stuff. There's some bits and a microwave oven. This base, that was a heat sink for the thyristor that they use, a triac. Actually, it's what do they call this thing? Anyway, thyristor, heat sink. These two coils, just little coils of wire with pole pieces in them. Those were buzzers out of an alarm system, warning buzzers. Like I said, I built this around 1980-81, and when I first made it, right now it has 4 magnets on the rotor. They're just Alnico magnets, they're no neodymium or anything like that. When I first made this, it only had 2. That was the first start, and it only had 1 coil, and it had 1 timing switch. This has 2 timing switches. I think they're a little difficult to see, but mounted to these little brackets are Hall effect switches. They're solid state magnet detectors, so think of it that way. When the magnet gets in front of this, it turns it on. That sends a signal down to this circuit. I'll explain a little bit later. What it used to be is I had a mechanical reed switch here. Mechanical reed switch is 2 metal reeds sealed usually in a glass bulb that are apart, and when you put that switch in a magnetic field, the 2 reeds pull together and close the switch. So that sends a signal, or that sent a signal, voltage actually directly to the coil, and it worked. You know, thump 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 thump. I didn't have access to some of the electronics back then that we even have now. Just didn't exist. Or if it did, I couldn't afford to buy it. And Radio Shack didn't carry that stuff. These days you can get this stuff digikey all over the place. So at some point, I said mid-90s or something, I got to playing with the thing again and decided, well, you know, I got some time on my hands. I'll improve it. So I added 2 magnets, added another coil, and added another switch. Only this time I used these Hall effect switches. Both of those Hall effect switches just indicate the position of this rotor so that the circuit knows when to turn these magnets on and off. Now, there's no power applied to this right now. The magnets are attracted to the pole pieces in these coils. What happens is when this magnet turns on this Hall sensor, that gets fed down to this circuit here, he switches current on through this magnet, which then repels the magnet that's now being attracted to it, pushes it out of the way. So it turns. As soon as it does, the same thing happens with these two. This sensor, position sensor, and this magnet. Now that electromagnet coil. So this would be a two-phase brushless DC motor. The circuit down here, see, zoom in on that a little bit. Doesn't get blurry. Not a lot to it. Just a couple of MOSFETs. They're basically switches that can handle the current that these coils need. It's not a lot, but it's a lot more than what these Hall effect sensors can drive directly. So think of this as a Class D amplifier. The polarity of what comes out of these sensors I happen to have was opposite what I wanted to turn these gates on. So I had to invert it, but both of those two signals, no big deal. A couple of bipolars. I think they're 2N222s, maybe 3904s. I forget now. These are IRF 540 or some equivalent. They're cheap and work really, really well. That's just a filter cap to help, power supply these long leads and everything. Makes it run smoother. It's also got a cap. Let's see if I can see right here. That's a bipolar electrolytic, meaning it's not polarized. A little bit of an unusual beast. Well, you can still get them. That was 4 microfarad, 50 volts, looks like. Yeah. And that, where that's connected, is actually in between these two coils inputs. And what that does is whenever you collapse a magnetic field on a coil like this, especially with iron around it, it backfeeds an opposite polarity. That gets coupled through this cap, and the value of this cap's chosen so that timing of that backfeed actually feeds the other coil just at the right moment. And this thing, like, just adding that doubles the RPM. Now, I don't know a lot about what it does to torque because I haven't checked that. It can drive small things, but it's really not intended for that. More of a conversation piece, something to learn, experiment. Really the whole point of it. Now, that radio I was showing earlier, the variable capacitor, the tuner, this is what this is, only with all those stupid little plates on there that we didn't need. So they just pick off and PR needle nose pliers and yank on them. They pulled right out. And so that served as my bearing. It's actually ball bearing drive, or a ball bearing captive shaft. Single ball bearing at the bottom. With the bottom of the cup or shaft is cupped, and the top is actually almost looks like what you'd expect from a sealed ball bearing, although it's not sealed. Ball bearings up there, you may be able to see them. So that's that. Just another thing to stick on the mantle and display and collect dust. Back up this a little. You see I've got written on here 12 volts. You can put more into that. I could put 48 volts into it, but it'll spin so fast, these magnets, this wheel will fly apart. It's happened. This wheel's been replaced a couple of times. This wheel is actually what the dial cord used to actually wrap around in the radio that this tuner came out of, or a similar radio. So that's only meant to handle the stress of you turning a tuning knob, not who knows how many G's with these heavy ass magnets strapped to it, which were originally just epoxied on there. That became a problem because it would separate, the magnets go flying off. So there's nylon ties here holding those in, along with some sort of cement, I forget, probably epoxy. So if I don't go above 12 volts, the RPM won't get too high and cause problems. But I have a 12 volt cell or battery handy right at the second. But the thing will run just fine off of a 9 volt battery. And in fact, this one's not even in the best condition. The last I measured it was a little over 8 volts. And you give it a spin. It takes a while to spin up. And also, I got to tighten the screw. I messed up the timing by touching this. You can affect the timing and how well it works by moving these around. And there's always, with these things, a sweet spot for speed that may not be the sweet spot for torque. Sometimes you gotta arrange matters so that you get a decent trade-off. And you know, I can put a squeeze on this shaft. It'll push, but it does not have a lot of torque, nor is it meant to. When I made it, first saw that thing spin, that's all I cared about.